Question 6 then. Question 6 showed obviously a conglomerate, and it asks you to describe the evidence from figure 6, so this is the photograph, that suggests these conglomerates were deposited by flash floods. Now the first thing that comes to mind straight away, the fact that it is coarse grained. So the fact that it's coarse grained equals to me high energy, and that's what you'd expect in a flash flood, so that would be 1 mark. The second thing is the fact that it's poorly sorted. You've got big clasts here, over here and here, loads of big clasts, medium class and fine stuff as well. So poorly sorted is another piece of evidence from the photograph, and that would tell me that it was that energy fluctuated and there was rapid deposition. Because if there was slow deposition, the big bits would drop first, then a bit later the medium, and a bit later the fine. But as they're all dropped together, it tells me that the energy was fluctuating. Again, something you'd see in a flash flood. That would be a 2nd mark. You can see here, we're describing the piece of evidence and telling the examiner why that is a piece of evidence for a flash flood. The last piece would be this information they've given you here. They've given you this for a reason. Now you don't need to know what imbrication is, I have mentioned it. What it is rocks, especially elongated rocks, big rocks, will line themselves up like this, and they indicate the current direction, and this is the current direction in my diagram here, same to these ones. These are all elongating themselves in that direction. Obviously if the current had come the other way, it would have tipped the pebbles the other direction. So the final bit, this is the imbrication. The imbrication structure tells me that there was 1 current direction and 1 current only. Again, what you'd expect in a flash flood. 6a part 2 had 2 parts to the question. If you look carefully, it asks you to describe and suggest an explanation. As it's 2 marks, I would suggest it's 1 mark for a description and 1 mark for an explanation. And what are you trying to describe and explain? Well, you're trying to explain the variation in thickness of the conglomerates. And you have to go to look at this. So if we look here at the map, at the cross section, and you can see here, they start off thick here, and they go thin. All of them start off thick and they go thin. Alright. Now, this cross section, let's just check which way it goes, is going basically, where's P? P's up here, and P's up here, so it's the north, and Q is in the south. So if we have a look at the cross section again, P is this end and Q is the other end. So if we had to describe the shape of these beds, they would be going thinner towards the north. So that's your description, towards the north. As you can see here, they start thick on this side and go thinner. All of them do that. That's your description. Now how can you explain that? Well, they've told you this sediment is from a flash flood, a wadi of some sort, and obviously as the wadi flows out over the flat valley floor, it loses energy and drops less and less material until eventually it peters out. Hence it goes from thick to thin. So basically a reduction in energy in the flash flood would be the reason why they go thinner towards the north. Question 6b was a giveaway 3 marks. I think only one of you managed not to get 3 marks, and it was just being fairly accurate with it. So for example, the northern one had to be up about here and all shaded in to get 1 mark. The northeast had to be to 25, which is about here, and shaded in for the 2nd mark. And well, I wouldn't have got many marks, would I? That's the wrong one. So let's go back on that one. and get rid of that, start again. So the northwest would be 35. We have to read the question like I didn't. There we go. And then the northeast was 25, which is somewhere in there, and shaded it. Simple. That's what you needed to do to get your 3 marks. Now, 2 marks to describe the variation in the paleo current. And for 1 mark, obviously, I would say the paleo current flowed towards the north. As you can see, virtually all the conglomerates have a orientation towards the north, so that would be 1 descriptor. You could say they spread out from northeast to northwest, that's another descriptor. You could say there's few to the south, that's another descriptor. So any of those would be suitable for 2 marks. Now, the next part of the question, figure 6a, that's the photograph you saw previously of the conglomerate, represents the most typical paleocurrent direction. Estimate the probable direction which the camera was pointed. Now, the camera, I'll have to get the photo for that, so I'll just get the photo. Here's the photo then, and we know the paleocurrent is going in this direction, which we know from the rose diagram that's probably a northerly direction. So if we're looking, if this is north, this direction must be to the east. Part C was the extended question, the question that made you think and showed who was an A grade or B grade student. So it says explain, so give reasons why the Southern Uplands Fault may have influenced the paleocurrent directions of these conglomerates. So if we look here, and we can see the, so make it a bit bigger for you. Here's the Southern Uplands Fault. Right, that goes northeast to southwest, we know that. All the conglomerates are in here, all in this area here. You can see the CG. We also know that the most common paleocurrent is to the north, and to the northeast, and to the northwest. That's what the rose diagram told us from the imbrication structure in the conglomerates. Now this question is asking, what influence do you think the Southern Upland Fault had on this direction? Now, if I draw what it might have looked like in the Silurian Devonian period down here, let's see if I can move it all up. There we go, I might get a blank bit of paper. So this is our fault. Remember, it was a normal fault. This side got pulled away, and this would have dropped down like this. Obviously, it's got eroded off to level it off, but when it was first formed, there was what's known as a fault scarp, because it was a dip-slip fault. One side's gone up, this side's gone down, that side went up, so it'd be a fault scarp. And any river running over here in this direction would go down the fault scarp into the valley. And as you can see from here, this is the fault edge, so the fault, this would be the raised up block here, the upthrow side, and all the rivers would flow in this direction down the valley into the fault formed valley. And that's the answer to part C.